Now that we've gotten through the chapter, let's just take a look at a couple of these problems, reflect on them, and see how could we have checked our work. So looking at the last one we just did, this tangent of x over 2 minus the sine of x from 0 to 2 pi. I want to be able to check this numerically and graphically using my graphing calculator. I solved this algebraically, but remember there's 4 different ways that we can look at functions, and the other 2 types of ways that we want to look at specifically here are the graphical and numerical. The verbal, I think you can explain if you had to how you came up with it. But let's look at this from the graphical and numerical side. So I'm going to start off by going to my graph, and I'm going to graph this function. So I'm going to go to y equals, and I've got the tangent of x divided by 2, so tangent of x divided by 2, minus the sine of x. And this is equal to 0. So I'm going to put y1 equaling the left-hand side of my equation, y2 equaling the right-hand side of the equation. And since I'm going from 0 to 2 pi, I want to make sure I'm in radian mode, which I am. Now if I just go and hit graph, I'm going to see some interesting parts of the graph. Let's set my window so that it actually makes sense for what I want. I want to go from 0 to 2 pi. So let's set our graph window to be 0 to 2 pi, which we have there. My x scale, let's set it just at pi over 8 for now. We've got a lot of different things we could use for it, but since I've got pi over 2's down here, I probably want to use some sort of factor of 2. I'm just choosing pi over 8 just in case I made a mistake and there might be some additional solutions. So then my y min and max, -5 to 5, y scale of 2, I think I'm good with that. And with my x min, even though I'm going from 0 to 2 pi, I might want to go a little less just so I can see the whole picture for what I'm looking at. So I'm just going to go -pi divided by 4. Just so I've got a little bit more on the left-hand side. So here's my graph that's being drawn. Graph that we have not seen before. Interesting shape. It's got the characteristics of both sine and tangent, where you have this asymptote right here, and then we sort of see the curving of the sine graph. And let's confirm my answers. We want to see where does the graph intersect 0. Since my right-hand side of the equation is equal to 0, that's what y2 is. Let's go second calc, and we're going to find the intersection of these two graphs. So I think there's an intersection point right there. So we'll hit enter 3 times. And sure enough, intersection is 1.5707963, which 1.57 is pi over 2. If I continue along and I calculate and I find the next intersection, looks like it's going to be right there. And sure enough, 4.71, which is the same thing as our 3 pi over 2. And I can see right there the graph does go through 0, 0, which is the final solution that I had over here. So that's how I can look at this graphically and determine what my solutions are. What if I wanted to look at it numerically? Well, that's where I look at the table. So go to our second table, and we'll start our table at 0. My change in table, once again, let's just do pi divided by 8 to make sure I didn't mess up with anything. And hit second graph this time, and I'll see the table. And what I'm looking for is I want to find the y1 and the y2 where their values are equal. And then the x column would be my solutions. So here at 0, y1 and y2 are both equal to 0, so 0 is one solution. Here I see y1 and y2 being equal, and that's 1.57, which is my pi over 2. If I scroll along, I should see another one at 3 pi over 2. There's that asymptote that we saw before at pi. And sure enough, 4.71, which is 3 pi over 2, there I've got identical y1s and y2s. So that verifies my 3 solutions between 0 and 2 pi. So there's my 2 pi, which would start the next cycle again, but since I had a parenthesis there, I don't include that answer at 2 pi. So that's one problem we looked at. Let's look back at another one we did. This is back from page 101. Solve 2 times sine squared of x over 2 is equal to the cosine of x. Let's look at this one both graphically and numerically. So first in y1, I'll put in the left-hand side of the equation. 2 times the sine of x divided by 2 squared. And I've got to put parentheses around that to make sure I get my entire sine function being squared. And then in y2, we'll put the cosine of x. And for my window here, I'm going from 0 to 2 pi, so my x scale would be fine, so should my y scale. And we'll hit graph. And there's my 2 sine squared of x divided by 2 function. And there's my cosine of x function. Once again, I'm in radian mode since I'm going from 0 to 2 pi. And I want to find the intersection of these two lines, which is right there and right there. And those should be at pi over 3 and 5 pi over 3. So let's verify that that's correct. So second, trace, which will take us to our calculate screen, and we'll do intersect. So we'll move our cursor to where we think the intersection is. And just looking at my first curve, I'm going to be pretty accurate. Yeah, 1.041, that's pi over 3. And if you don't believe me, plug pi divided by 3 into the calculator and get the decimal equivalent. And then if we scroll all the way over, we'll find the intersection of these two lines. And there's 5.23, which is our 5 pi over 3. So same thing is true here with the graphs of these two functions. Where the intersections occur are my solutions. If I wanted to do this one numerically, we could do the same thing by looking at my graph. Actually, I want pi divided by 3 there, not pi times 3. We'll start at 0, and we'll look at our table. And once again, I'm looking where y1 and y2 are equal. They don't have to be zeros for both of them. I just want to find equal values. So right here at 1.047, I see I've got a 0.5 for both of them. So 1.0472 is one of my solutions. 2.09 won't be. I've got two different numbers there. Pi won't be. 4.18 won't be. But then there's that 5.236, which we see a 0.5 in both of those. So there's another solution, which is my 5 pi over 3. So we've verified both of those graphically and numerically. Let's look at one other type of problem that isn't a graphing problem, but rather a simplification problem. And this one comes from our sum to product formulas. The very first one here. Find the exact value of the sine of 195 minus the sine of 105. Well, since we're in degree mode, let's go to degree mode and find what the sine of 195 minus the sine of 105 is. And you can see it's negative 1.2247. We can confirm that's right with our exact value by plugging in negative square root of 6 over 2. And I can see I get identical decimals. So there's another way you can verify some of your exact values. Plug in your equations into the calculator, get the decimal equivalent, and then plug in your final answer and see, is your decimal equivalent identical to your other solutions?